1980s, when I was working with a physician in the labor room, he wanted to see medical imaging in 3D. This is an order of magnitude more complex than 2D images. Very quickly I realized that we need to develop hardware, we need to develop architectures to deal with this kind of tremendous amount of data. And the first development was the Cube 1 architecture, which you can see a prototype right here. This one has 16 printed circuit boards that we are working in parallel and generating a 16 by 16 by 16 image of a 16 by 16 by 16 on a screen. When I joined Stony Brook in 1985, we developed a chip, and this chip has 16,000 transistors in 2-micron CMOS technology, and 16 of these chips did the work of this entire prototype. 2 generations later, we developed the Cube 4 architecture, and this was licensed by Mitsubishi Electric Research Lab, and they developed a PC board. You plug it into your PC and you can have 3-dimensional medical imaging on your PC. You can have 3D exploration of oil in the Gulf of Mexico on your PC. So this was a very innovative technology. We also licensed it to Japan Radio Corporation that builds a 3D ultrasound device. We developed the virtual colonoscopy, which is a mass screening technique for colon cancer. It was an idea that I had while walking down the corridor. If I can see down the corridor, I can see down the colon of a human being. So we started to develop this virtual colonoscopy technology, which in 1999 the university licensed to Viatronics, which is a startup company in the incubator. You can see here the user interface for the physician provides a video game inside the colon of the human being. We take a CT scan of the abdomen, 45 seconds in the 90s. Today you can do it in 1 second. 1 second scan of the abdomen, we get hundreds of cross-sections of the abdomen. We make a 3-dimensional volume of the abdomen and extract the colon out of the abdomen, electronically cleanse it, and then we provide the doctor tool to navigate down the colon, look for polyps. The polyps are the precursor of colon cancer. Basically, the screening of choice now for colon cancer. This was a very successful technology. We licensed it to Viatronics and then to Siemens and a few other companies. It's thousands of these machines around the world, and we saved a lot of lives. The next technology I want to describe has to do with virtual reality and immersing the user in the data. Right here in virtual colonoscopy, we look at the desktop screen. It's very limited field of view. In the immersive cabin, which is a cave-like facility with 5-sided walls that we project on them the data, we immerse the user inside the colon. The user can actually walk inside the colon. We can fly through the colon inside, and we basically see 100% of the surface. Therefore, we don't miss any of the polyps. And because of that, we can have a better mechanism to find polyps and eradicate colon cancer. Other applications of the immersive cabins are in architectural design. We have, for example, the design of the Simon Center. It's good for city planning. We have it for applications for defense applications, for the Navy and Homeland Security, drug design, and even training of police. More recently, we put together the reality deck. The reality deck is the 1.5 billion pixel display. It is the largest resolution display in the world. 1.5 billion is 5 times the next size tile display. And in addition, it's an immersive one. It surrounds the user with displays, and the user feels inside the data. Furthermore, The amount of pixels, the amount of resolution that we have allow us to see in 2020. This is exceeding the accuracy of the eye even. So basically you're inside this facility and you can see an overview of the data, but at the same time, if you're looking for details, you just walk closer to the screen and you can see the minute details. This is basically a facility to investigate large data, and this is really the way of the future to look at big data. You know, biologists, weather prediction, flood zones, all of this we can see in this facility, and they will allow scientists, engineers, physicians to change the way they do science and medicine today. This is really a facility of the future. The name Reality Deck was borrowed from the holodeck. The only difference is holodeck is science fiction, but the Reality Deck is real science.